All right, hey guys, today I'm going to be looking into some of the essential macros and subroutines that you might want to set up in your project when you're starting. Basically, just starting from a clean slate over here. This is basically the end of my other series all about the basics. And in this video and just for future things, we're basically going to be trying to be independent to the extent that I'm not going to use the debugger or anything like that. We're just going to code. We'll make any macros that we need to print to the console and convert, integers to strings and vice versa. And this will basically just that'll be basically what this video is about. Just kind of those essential things that will help us for any project that we do debug different problems that we have. Because if we can easily print data that we're working with, then we can figure out what's wrong a lot quicker. Other than, you know, I mean, initially you kind of all you have is the exit code, and you can just set that and say there's a bug happening over here. We just, you know, set the exit code to something that we're testing, and that's not that good. That gets annoying pretty quick. So first, I want to clean up this file structure that we have over here. I'm gonna make an include folder, and that reminds me. I just want to say that these videos are not supposed to, you know, I'm not trying to tell you what is correct or need to do. This is just kind of, what I do, and hopefully it can give you some inspiration. That being said, if you want to recommend things, if you have ideas, I'd love to hear it, and I'd love to implement it if I think it fits. By the way, over here while I was talking, I just made a folder called include, and I'm going to put any uh, other files that I'm gonna include in here, and I'll just have my main uh, file outside of that. I did update this right here to be include/io rather than just io. All right, so the first thing I want to do is probably first I'm just gonna get rid of what we have here. I mean, we can print hello world. Well, let's not do that yet. Let's just get rid of this, and I want to also clean up what we have in here. I mean, these macros, I want to make them a little more versatile. I want to be able to use them in more ways. First off, I want this to be not just to the console. This file descriptor right here, this basically is telling Linux when we do the syscall where to write the string that we pass through. But if we are writing to a file, even in read, if we're reading from a file, we're not going to do one. We're going to pass in the file descriptor that Linux tells us when we open a file. So I do want to just make this have 3 parameters and, you know, basically do this. And we'll move racks at the end, RAX, just because I I think, if one of the parameters passed in or the arguments passed into this macro is RAX, I don't want it to get overwritten, and I will decrease the chance of that happening if I put it at the end. I can't help this because these, will be overwritten by the parameters, so I just try to keep them in order of the order that we use, RDI, RSI, whatever. Uh, I talked about that in my other videos. I'll see if I can maybe I'll add that to the top once I'm done with this. But basically, I'm moving RAX to the end just to decrease the chance of overwriting, and also to help myself later on whenever it's been a while since I've written this. Also, I do want to specify that this is writing a string. We're using this for, well, we pass in a string, and maybe later on we'll add things that print integers, the hexadecimal representation of an integer, whatever. So, a lot of times to do that, people, or also because others do it, is you put an S in front of it. So it's a string right. Another thing that I'm thinking though is later on, I might start using a string struct or a struct that holds the address of a string of characters and then also the length And if I, in the future implement our own malloc or something like that, then it can also be like its maximum capacity, whatever. So I kind of want to reserve that word to mean that struct. So for now, I'm thinking this is basically, it's an array of characters. So I'm just going to call it car with two R's. So maybe it's a little bit of a mouthful, but I think we can get used to it, whatever. So this one, also car. Car read. There's three R's, whatever. Well, I mean, it's really not that bad. So, um, after doing this, I also do want to comment my macros so that whenever I reuse them later on, it's not too difficult I don't have to, go through each line and figure out what I was doing, whatever. All right, so I have this one copied, and we can go through it and see if I need to change anything with the implementation that we have right here. So first, I pretty much put the function declaration like for macros, subroutines, whatever, just to give me a quick glance of how we're going to use this. So it takes three parameters: the file descriptor, the source of the character array, and the length of that character array. This is the name of the macro or subroutine, and then here's what it's going to return. I also like to put this line right here because if I call or use this macro elsewhere, I'd like to know what registers I need to save because they will be overwritten. I usually do not add RAX to this list because if it returns something, I'm not going to add RAX to this list because it's assumed. Also, right here, I sometimes will describe what the return value of the macro or subroutine is, if it's not obvious. If it's converting an integer to a string, that's obvious. That's the whole point. But this one, uh, just because this is how the syscall works, it will return the number of bytes written or -1 if there's an error or whatever error code. So it Linux will automatically, with the syscall, it'll store uh, this into RAX. So I just wrote that here. I put the int there. All right, so for down here, we'll do the same thing with this macro. And I also want to add RAX to the end as well and make sure the file descriptor is passed in. And the nice thing is we can just copy and paste this comment that we have from earlier and just change a few things. So all I changed was I fixed the name and then I changed this to destination instead of source. Really doesn't matter too much. Right, next I do want to make specific macros for the terminal though, because yes, this is nice to have a versatile one, but most of the time, at least in this video, we're going to be using just the terminal. Well, all of the time. We're not creating any files. So, uh, I've shown that macros are made using this notation, but that is technically only for multi-line macros because this is just going to be one line, you'll see. Uh, we just type the word define, and then we will write the name, and then instead of writing the amount of parameter or arguments, we'll just write the arguments in parentheses for a single line macro. So we need the source and the length. Put that in parentheses with columns. Make sure not to put a space here. And then after the space, we can write what the macro will become. And since it's a single line, or because we're just calling this macro, it's a single line macro. We only need one line. So it's car right. And then we'll pass in 1 for the file descriptor. And then we'll just or put a comma. And then we'll do the source and the length. It is good to note, let's go back to our main file with this new macro. And in here, we'll use it, and because it's a single line macro, now we also use it with parentheses. Before we would just put one message length, but now, because it's a single line macro, we're putting these arguments in parentheses. So that's just something to watch out for. When we run it, it works, so everything's good. And now we have a pretty simple way of printing strings that we have stored in the data section. And now we can also create the terminal version of car read. So I'm just going to call this car input. I changed write to print and read to input. I think that makes sense. And we'll be passing in the destination and the length, and when we call car read, file descriptor is 1, pass in the destination and the length. So, I mean, I'm not going to test this one. I'm pretty sure it works. All right, now we're going to create a new file, and this is going to be more about manipulating these character arrays or cars. So the first thing that we're going to do is we're going to create a macro that converts a character array that contains digits into, here, and we'll even be more specific with this. All right, so it's going to turn this character array that contains digits into the actual integer representation. Because remember, when we're holding a number as a string or a character array, that it's not equal to the actual value of that number. And this occurs if, you take user input from the user, when they type in the terminal, it's it's a character. These are all characters. This is not numbers. So when we get the user input, it's stored as, a character array. And if you need to get the integer value of that to, say, do math or whatever, you're going to need a macro like this. All right, so let's start by moving the two parameters into RDI. And then we're also going to create a loop using a local macro label. We create that with these double percent signs. And then we're going to go through each character in this loop and say we're given 9 as or 0 as a character. Well, if we subtract the value of the character 0 from this, then obviously we're going to get 0 because something minus itself is 0. And if we get 1, if we're iterating through it and we get a 1, the value of a 1 character is 1 more than the value of a 0 character, so that will give us 1. And this is true until we get up to 9. We also get 9. So all we're going to do is we're going to iterate through each character, subtract the 0 character, and then add it to our result. Now, before we add it to our result, we're going to make sure that we multiply our result by 10, because say we are given a string with 98. First, we go through each character. We're going to start from the left. We're going to see 9. We add 9 to our result. Now, before we add 8 to our result, we're going to multiply our result by 10 and then add 8. If it was 981, we would get 1 next, multiply our result by 10, add 1. So, as you can see, this is a very simple but effective way of converting a string to an integer. And our result will be stored in RAX, so at the beginning we are going to make sure that RAX is set to 0. Now you might be thinking, why didn't I move 0 into RAX? Just know that this does that, but sometimes more efficiently. I don't really know if it matters, but I do it just because it technically can be more efficient. If it doesn't make much sense to you, you can just move 0 into it. It really doesn't matter. But I'm going to do that. Now, as we go through this loop, we have the length of the string in here, and we're going to decrement it at the end, and then jump to the beginning. So basically, once the length, or once this value is equal to 0, we know we're done. So we're going to compare RSI to 0, and if it's equal, we will jump to the end. All right, so if we're not at the end of the string, remember first we need to multiply our current result by 10. The way multiplying works is you give it a register, let's just say RCX, and it will multiply whatever's in RAX by the value of this register, which is perfect for us because our result is in RAX. So we just want to, at the beginning, move into RCX 10, and then now every time we call this, it will multiply RAX by 10. And the reason why I didn't go to RDX, because that would be next usually, is because after multiplying, the upper 8 bytes of this multiplication result is stored into RDX. And for us, that's always going to be 0. So RDX gets overwritten whenever we call this operation. So next we're going to actually want to get the character, and we'll move it into RDX because we're only going to need the character until we loop again, and it'll get overwritten at the beginning of the loop. But now that we're after the multiplication instruction, we can just clear RDX, remember you can just move 0 into RDX, but I'm going to XOR it. And then we're going to move into the lower byte of RDX the value at the string. And we do want to make sure that at the end we also increment the address that stores the string to make sure that we are accessing the next character and not repeatedly accessing the first character. That would not get us what we want. So we'll move that into here. And then remember, we'll subtract from DL the value of the 0 character. If DL holds the value of the 9 character, this will now subtract the 0 character, giving us 9. So it's exactly what we want. And we will add that value to RAX. Believe it or not, we are done with this macro, and let's make a simple program that uses it. So let's just make a program that asks for a number, a 1-digit number, and that will be the program's exit code. So we are still kind of using it to test our program, but hopefully we won't be doing that for long. So I'm just going to say enter a 1-digit exit code, put space right there, and we will call the car input, and we will, oh yeah, we first need to make the user input in the BSS section. Just going to be 1 byte. So we'll pass this in, we'll pass in the length of 1, and we can go check to make sure that this makes sense. We have the destination and the length. So that makes sense to me. Now that user input has that, we can then call the car to I, which is character array to integer. Car to I, the address of the string and the length of the string. And now we know that RAX holds the integer, so we'll move into RDI that value before we set it to 60. And then now let's test this. I did forget to include that file, so let's just do that real quick. All right. Oh, I forgot to print the prompt, but that doesn't matter. We'll just enter 2. All right, and then to print the exit code, we can just run this, and it gives us 2. So that's great. That's exactly what we wanted. And you know what? Just to make it a little more complete, we can print that prompt. And then let's retry that. Enter a 1-digit exit code. I did forget to get rid of the new line. Good job, me. But we'll enter in, let's say 9, and echo that, and we got 9. So it works. Let's now do a 2-digit one just to make sure it doesn't break. We'll say 2 here and 2 there. Oh, and then has to be 2 bytes large. We'll say 21 and then echo that and we get 21. Now, if you are testing this and you do a large enough number, I'm pretty sure this exit code is only like a byte. So whatever 255 or 256, one of those, that's the maximum value. Once you get past that, it starts looping back to 0. So, if we did this with 4 digits, it would give us a random number that, I'll show you it. If I enter in 1, 2, 3, 4, and we echo this, we do not get 1, 2, 3, 4, but that's okay. That's supposed to happen. All right, so here you can see we're now going to make the reverse macro, which converts an integer to a character array. And now the problem is if we want to call this macro wherever, without preparation, say we're in a loop and we don't know how many times we're going to call this, well, to store a character array, we need to allocate that memory, but we can't do that ahead of time if it's just going to be called, throughout the program basically randomly. So this one will be creating the character array on the stack. That means that this one actually has to be a macro. This one could have been a subroutine. I'm just not doing subroutines because I think it'll be interesting to try to do macros as much as we can. But for this one, this if it was a subroutine and it started on the stack at the end, whenever you return, either the program would crash because the stack pointer is not in the right spot, Or if the stack pointer is in the right spot, it basically is just getting rid of that character array that you made on the stack. So we are going to start with decrementing RSP by 1 and moving to that new byte that we just made on the stack. And remember, we're decrementing because the stack grows down, not up. So this is allocating a byte. Anyway, we will move into this new byte the value of the null character, the ending character, which signifies the end of this character array. We're doing this because there's no way for the macro caller to know the length of the character array once we're done. We're returning a pointer to it, but there's no way for them to know the length. This provides them a way of finding out the length by counting through it one by one until they get to 0. So let's start by creating our loop, and then we'll make the end of the loop. And we're actually not going to be using RAX until the end. At the end, we're just going to move into RAX, the value in RSP, because it's going to be pointing to the beginning of the string. Because remember, it grows down, so the last character that we put on is actually going to be the first character in the string. So at the beginning of the loop, the first thing we're going to check for is the value 0, because that means we're done. So we'll compare RAX to 0, and if it's equal, we will jump out of the loop. Now, there is a problem, because if 0 is passed into the macro, the first thing it's going to do is jump to the end, and there will be no character. There won't even be a 0 character. So we do have to kind of hard code in this scenario. So we're going to compare RAX to 0 before running it, and then we'll make a local label called is0. And now, the reason why we're still keeping this in here, by the way, is because, as we go through each digit in this value that's passed in, we're comparing it to 0 to see if we're done converting it to a string, or if we need to convert more digits. And we're doing it before the loop, because if all they pass in is 0, then we're not going to have added any characters to the stack, and it will just jump out of it. So we need to add something if we're given 0. So if we're given 0, we will jump to the is0 label, and we will decrement RSP by 1 and move into there the 0 character, and then we're done. And now that this is not just for the loop, I will rename this to done, just because it makes a little more sense. At the end of this loop, we do want to make sure that we jump back to the beginning. All right, so the first thing that we're going to do is we are going to do some division. Basically, if we're given 1,234, what we can do is divide that by 10, which will give us the value in RAX, the value in RAX, and the remainder in RDX. As you can see, this is the first character we need to add on. Also, luckily for us, because we're starting from the right side of the digit and the stack grows down, we will end with the leftmost digit being the first character that we print, which will lay it out perfectly. So first we'll need to divide RAX by 10 to do this. So at the beginning, we will move into RDI 10. And one very important thing to note is that when we call the division operator, it's combining the bytes in RDX and RAX. And whenever I say combining, I don't mean adding, I mean like concatenating together. All right, so say for some reason a register only holds 2 bytes, that's not true, but let's just, for example, if RDX holds a byte with value 2 and a byte with value 3, and RAX holds the value of a byte with a 5 and a 1, then what we're essentially doing is just squishing them together as if we had a 4-byte register, and then dividing that by 10. In this example, or in our scenario, it's really 8 bytes. So now it's a 16-byte register being divided by 10. And because we don't need all of that room, we're just gonna clear RDX. This will allow us to now divide whatever's in RAX by the value in RDI, which is 10. And now, as I showed here, RDX does hold the character that we want to add to the string. So we will add to RDX the value of the 0 character. This is like reversed from what we did earlier where we subtracted it. Now we will be adding it. And here we did subtract from DL. Let's add to DL because it's more symmetrical. Whatever. Doesn't really matter, but it's a little more satisfying. Next, like we've been doing, I'll just copy this. We decrement RSP by 1 to make room for this byte, and then we'll move DL into that location, the value of DL into that location. I'll clean this up a little bit. I'll leave this comment here just in case you're ever confused if you see this again, why we are clearing RDX. Did realize I made a weird mistake. I combined the subtract and the decrement operator. Obviously, it's just dec, so let me fix that real quick. If you notice that, I bet that was a little frustrating, but there we go. It was a quick fix. So yeah, I saw that down here whenever I tried to test it. Basically, we're going to get rid of this old code, and now we are going to just print the value of a random integer. So let's convert it to a character. We'll pass in the value 12, and then now RAX should hold the address of the string that we will want to print. So we will car print RAX, and it'll be too long if it works out, which it looks like it did. Oh, and I did forget to fix the error code thing, but that doesn't matter. It worked. So we got 12 printed. All right, so now that we have done this, I want to make some IO macros that utilize these macros that we made to say maybe make, we can make a macro that instead of car read or car input, we can make an I input that gets an integer from the terminal. But just as a precaution, what if, you know, we didn't include car and we are including IO and we don't want to use those other macros? Well, basically, the way that we can determine if a file is included is at the beginning. I will write define, and then I'll just make a random single line macro. I'm not even going to give it a value or anything. I'm just going to define it. And later on, we'll just test if it exists or not. And I'm just going to call this by name underscore and what it is. So this is car. Another benefit of this is, let's say that we included car in the main file, but IO or another file, whatever, includes it. Well, now we're going to have, when we include IO, we're going to have car included twice, and we're going to have two definitions for all of our macros, and that's just, the assembler doesn't like that. So at the beginning of this file, we're also going to say, if Caden car is not defined, then we're going to add all these macros and stuff. And then right at the end, we'll do an end if. So basically, just only do this if this single line macro has been defined. Let me fix this typo. It should be if not defined. So we will do this in IO as well. Obviously, if you're doing this, don't put Caden unless you happen to have the same name as me, which if you do, that's cool. All right. So now that we have this, we will go to the end of our file and we will say if Caden car is defined, then we can add some IO macros that utilize the car macros. So let's start with this. We converted an integer to a car and then printed it. So let's just make an I print. And also the nice thing about this is when we call this macro, it's moving the stack pointer, remember? Let's go to I2 car. I did want to point this out actually, is that when something creates local variables, when a macro creates local variables, I do point out that RSP is moved because that's pretty important to know right there. So I put it first. So basically when we're using this, we're moving RSP, and if we're only doing this to print the integer, then we might as well at the end move RSP back. And what we can do, what I should have done actually, is moved into the base pointer RSP, and then at the end moved into RSP the value in the base pointer. And that's essentially deleting this string that we only used to print. And let me just point this out while we're talking about it. If you do ever overwrite the base pointer, you want to make sure you push it and then pop it when you're done using it. Because other than if you're at the start label. That's because RBP is something that has to be preserved by the callee and not the caller. So when we create this macro that basically does this, we're going to make sure that we preserve RBP so that when we call this iPrint macro from other places in the code, it's not going to have to worry about the RSP register being moved or the RBP register being overwritten. So let's go to IO and let's actually copy our car write. We're first going to make it be able to write the integer anywhere. So we're going to make an iWrite and then we'll make the iPrint version just like we did before. So let's copy this. We'll bring it down here into the if statement and we'll change the name to iWrite. iWrite will be taking in two values. It's just going to take in the value to be converted to a car. So first we're going to want to call this macro. I'm just going to delete all this. We're going to call this macro. We'll put in the first value. Oh, and then obviously we're not going to forget to do this to preserve the stack pointer and the base pointer. This RBP is the base pointer, RSP is the stack pointer. So this will preserve both of those. This is the second argument, not the first. The first one is the file descriptor that we're going to want to write to. And we're going to want to save that before calling this macro because there's a chance that it can overwrite it. But what register should we save it to? So let's go to I to car. And I don't know if y'all noticed, but RSI doesn't actually ever get used. RDX does get used, but that's because of the division. So that's why it skipped RSI. But RSI is free. So we will, before calling this macro, we're going to move into RSI that first argument. And then now we can make a call to the car write. And it's going to need the file descriptor. And then RAX will hold the location of this string. And then I actually just realized we do have a problem, and it's that we don't know the length of this string. Like right here, we knew it was going to be 2 just because we had hard-coded this in, but how are we going to know the length of the string once it's done? So that means we're going to need to make a new macro that will find the length of, or not a string, a car, whatever. We'll make a macro that finds the length of a car by going through each character, incrementing a value, and then whenever it hits the null character, it'll be done. So in the car file, we're going to make this. It's car length. We'll find the length of a car. So we will loop through each value, and we will want to make sure that we store the value being passed through. And because the result will go into RAX, we will just clear that. And then basically, at the end of our loop, we will jump to the beginning. And before doing that, we will increment RAX. We will also increment RDI so that it will point to the next character. And then at the beginning, we will compare that character in our RDI to 0, signifying that we're at the end of the string. And if it is 0, we will jump to the end. All right, now that we have this, we can go back here and use it to find the length of our string. So before finding the length, we are going to move into RDX, RAX, and then we'll change that right here. And then we will find the length of the character array, and we have the location of that in both of these registers. I'm just going to use RAX, it doesn't really matter. But after calling this subroutine, our RAX should now hold the length of the character array, so we'll just put that right there. And now I do want to test this, obviously, so let's put iWrite. It's going to go into file descriptor 1, and let's do 12. And we get 12 printed, and we can even do something different because who knows, maybe it didn't assemble or something. And 24 works as well, so that's great. This right here, where we pass in, or where we have a string that we don't know the length of that we want to write, I do want to make that a macro itself. So back up here, we can actually make a new macro with the same name, but with a different number of parameters. So it's going to have a very similar description. It's just not taking in the length, but everything else is the same. And the first thing we're going to want to do is find that length of the character array being passed in. And then in here, we're going to call this syscall just like normal. So let's just at the end, just for consistency, move into RAX1 like we did before. And then right here we can move into RAX because that's where the length goes. RSI is going to hold the address, so at the beginning we can move into RSI that second parameter, and that's just to make sure that that parameter doesn't get overwritten right here. And then finally, we do need RDI to hold the file descriptor, and because car length modifies RDI, we know this thanks to this little comment, we will just push that first value, and then once this is done, we'll pop it into RDI. So now let's try fixing this or just changing this to do the car right without the length. So remember we moved this string location, it was in RAX, we moved it to RDX. We're not going to do that anymore. We're just going to keep it in RAX. Even though we don't use RDX in here, we do in car right. So that's why that is in this list right here. I didn't put RSP because we're not modifying it. We save it in the base register and update it at the end. So let's just test this to make sure it works. It should. I don't see why it wouldn't. Yeah, it works. So the next macro that I want to make, I'm pretty sure it's the final one that we'll do for this, is the integer input macro. Basically, all it's going to take in is the amount of characters to read. So, remember we type in like an integer, so this would be 4. So we're going to use this macro right here. We're going to do car input. And right now we don't have a destination to put that. So we'll just not worry about that for now. And we will just use that first parameter. Where are we going to store this car? Well, what we can do is we can just subtract from the stack pointer. Oh, I don't know why I put 10 here. We'll just subtract from the stack pointer the length, and then we'll pass in RSP so it can just store it there. Now, because we're messing with the stack pointer, we're going to want to do what we normally do when we do that, which is pushing the base pointer and then moving into that, the stack pointer, and then reversing that at the end, just to make sure that we don't mess with any of that, because now we're manipulating the stack pointer. Okay, now there is something annoying that will occur when we do this, and that is, say we use this macro and the length is 4. If the user inputs, 1,234, that's fine. But if they only enter in 123 or anything with 3 characters and less, the fourth character that gets, or the last character that gets saved is that new line that they hit when they hit enter at the end. And we don't want that whenever we're converting this to an integer. That's going to mess up our calculation. So let's move into RDI, the location of this string, and we will add to it the RAX, the output of this macro call. And remember, this macro call gives us the number of bytes read. So that will it'll actually point us to the character after the new line. So we'll want to decrement it, just go back one, and now we will be pointing to the new line or to the last character. If they entered in the maximum amount of characters, then now we're pointing at 4, not a new line. So we do have to make sure that we don't delete a valid character. So let's compare the character there to the new line value, which is 10. And if you want to see those values, go to ASCIItable.com or just look it up. You'll find an easy chart that shows it all. But I know it's 10, so we're going to compare it to that. I'll make a macro called no line feed, and I'll make a fake label called yes line feed. And what we're going to do is we're going to jump if it's not equal to 10 to no line feed, because we only want to do this if there is a line feed. So what we'll do is we know RDI is pointing to the line feed right now because of this. So we're going to move into that 0, signifying the end of the string. So we're just deleting it. The final thing we're going to do is we're going to want to convert. Finally, we can convert this car to an integer. So we'll pass in the location of it and the length of it. Now, if you remember, we do remove a character from the car if it's a new line. So we're going to want to make sure that we decrement RAX if we do remove it, so it gives us the right length. All right, now just to test it, we will do I input and we will do 4. And I did 4 just because I have this string up here. So we will do a car print that takes in the message and the message length. And oh, one thing I wanted to say is to be consistent, a car, let's just always end that with a null character, just so that if for some reason we want to use the car length macro on message, it doesn't break. Because if we used it on message right now, it would keep going, and I don't even want to know what would happen there. So we'll just put a 0 there just to be safe. It doesn't matter, it doesn't. It's 1 byte, so I think we'll be fine. So we're going to print that, and then we are going to take in 4 characters, and then RAX should hold the converted value. So we will pass that into iWrite and let us test it. Or actually, let's also get rid of the exit code part of this message, and let's just make it enter a 4-digit number. So we will do that, and I'll enter in 1, 2, 3, 4, and we get 1, 2, 3, 4, and it worked perfectly. So there's actually like 2 more macros that I want to do before we finish this. I do like to have a macro that just prints a character. So we're gonna just take in a character, we'll put it on the stack, and then we'll just use the location of RSP as the location of our car. So we'll decrement the stack pointer at the beginning, and then we'll increment it back to where it was, and we will move into that new location the value passed in, and then we will print that 1 character long message. This is great for debugging. If you're in the middle of your code and you don't know what's going on, you can just do a quick little character print, give it I if you're iterating through a loop, whatever, and right there you can see it printed I. So it's just a really simple way to be able to debug your code. And another nice thing to have is a little extension of this is just a macro that prints a line feed, and it's not going to take anything. It's a single line macro. It's just going to do cprint with 10. So the reason I thought of this because our code prints that integer, but it doesn't do a line feed, which just looks annoying. So now we can do that. And right there we have the line feed. Okay, so now this one's a little complex. It uses a lot of preprocessor things in it that I haven't really talked about before. I'll just show you it in action real quick, and I'll explain why it has this weird name. So let's just get rid of this and do this. And let's run our code. And it runs exactly the same. So basically what it's doing is it's allowing me to print a string without defining it in the data section. And that's just kind of a really useful when you want to debug. You don't want to have to go create it in the data section, get the length, whatever. If you just want to print it wherever you are, you're in the middle of your macro, and you can say like, test 1 and then, test 2 as you're, doing things, then it's just very helpful to debug. So let's walk through it a little bit. So first, I do save the stack pointer because we will be storing that string on the stack. And since it is the generic write and not the print, we do have the file descriptor coming in, and I just store it into RSI to save it for the end. So the first thing we're going to do is we're going to get the length of the string passed in using this macro. We're using this macro because it's a string literal. It's not actually stored like in the data section or on the stack or anything. Like the assembler is reading it right now, so it can find the length of it. So we'll pass in the string that is passed into this macro, and this is basically the label that will represent the string length that we get. So we could have called this anything. We could call this length, and then everywhere we use it, make sure that we put length. It's just the label it's like a variable. And then the next thing that we're gonna do is, so basically, uh, you can push 8 bytes on the stack at a time, or like 8 characters, because the stack, whenever you push something on it, decrements its value by 8, because registers are 8 bytes large, so you can push 8 bytes at a time. So what we're going to do here is we're going to get the amount of chunks of 8. And we add 7 because if we didn't do that, it would start at 0, and we want it to start at 1. And then we're also going to assign to this variable I the one less than the number of chunks, and you'll see why. And then we'll use this instruction called or it's the repeat instruction, and we'll do it the number of chunks amount of times. So if we have 2 chunks, it'll happen 2 times. First, it's going to make a substring, and remember, we're going to want to start at the end of the passed in string, because we want to push, this part onto the stack, and then this part, and then this part, because we want to end up having the first character at the beginning of the string. And because the stack decrements, it goes down, we have to start at the end of the string. So that's why right here, first off, I pass in, or this is going to be the name of the substring. This is the string that's passed into the macro, and we're going to start at I times 10 times 8 plus 1, and then get 8 characters. And let me explain this. Remember, I is starting at, let's say there's 2 chunks, I is going to be equal to 1. So 1 times 8 is 8, which will be the second chunk. And we have to add 1 so we don't repeat like the last character of the chunk before it. So this will be the last chunk the first time, and then it'll repeat, and you'll see that it'll then be the chunk before it, whatever. So after we get this chunk, we're going to move it into RDI, and we'll push it onto the stack, because remember, you can push 8 bytes at a time. And then we will assign to I minus 1. So that just is going to be it's going to do the chunk before the one we just did until we're done. And then we do the end repeat instruction right here. And then after we push all of those onto the stack, we're going to use our macro that prints a car. We'll pass in the stack pointer, and then we calculated the string length earlier. And then like I said earlier, we'll update the base pointer and the stack pointer. Don't worry if this wasn't the most like clear and obvious thing. It doesn't, like, you don't really have to understand this. This is a lot of preprocessor stuff, which is useful to know, but I feel like if you're if you're new or whatever, you don't I wouldn't recommend maybe focusing on this stuff at the beginning. Maybe later on when you start getting things more naturally. But I just thought I'd show this to y'all as maybe a little intro to it. And then also, as always, we will make the print version of it, which will take in the car and call the macro with the one file descriptor. And then real quickly, this is the end, but let me explain the weird name right here. This is a character array literal write. And it's a literal because it's not like stored anywhere in memory or whatever. It's just right here. It's just the literal value. So it's a carlet. So this is writing a carlet. I know it's weird. And this is printing a carlet. But anyway, yeah, this is everything that I wanted to do in this video. I'm hoping it wasn't too much, but I basically want to use these macros throughout the series. So I just wanted, or not the series, but throughout any of my videos. So I wanted to set it up now, and that way we can just use them later on and not have to worry about being confused why something's not working very well, if there's a bug going on, whatever. Anyway, so if you like this, please subscribe, because I will be doing more things related to NASM, hopefully more interesting. I know this was maybe a little tedious, but I think maybe the first thing I'm going to do is implement malloc, which is a function that you see in the programming language C. I want to implement that in NASM, and that will also kind of open up our opportunities, and it's also kind of interesting to implement. It's made from like a linked list, or at least the way I'm going to implement it. I don't technically know the real implementation, but it'll work. So I'm going to get to work on that. But for now, I thought I'd put this out here, get all the essentials out of the way, and we can just kind of hit the ground running with any other projects that we have. So thanks for watching, and I'll see you in the next one. Bye.